foot mounts before to adjust it. It's very easy, even at the extreme angles of both forward and back. And the final test was the handling drop test. Now this was a part of our original design that we decided upon because we wanted to make sure that it was to simulate a chair being dropped out of a truck. Each of the casters were going to be dropped. The chair itself with the full weight was going to be dropped from a full meter, and the chair was going to be angled such that it landed on each of the casters individually. Now that was to simulate them constantly transporting it. Like you don't want to have a wheelchair that someone uses every day fall out of the truck accidentally and break on its first run. However, that was the original thought. However, our chair itself is going to be designed to never leave the facility. It's indoor use only. It's not something that is designed to bring kids to their chair, bring them home. It's something mainly only for their therapeutic use. And also from the impact test, which we did first, we noticed that the wheels themselves were going to be the ones to break before the frame did. And due to budget constraints, we couldn't afford another $100 and some to replace all 4 casters. So that was one of the tests that we elected not to do after further revisions. And lastly, what we did was testing at McMahon's, which is where we brought the completed chair to them and allowed them to not only mess with the controls themselves, but also to put some of the patients in it and see how they reacted. First, like I said, the patient comfort test. Now this was while our patient was in the chair. We really just recorded his reactions. We talked to him, see how it was it comfortable, how did he feel in the chair, things like that, and we recorded all of his responses. The next was ease of usability. Now, we designed the chair itself to where all of the controls themselves are only accessible by the therapists. We don't want the kids messing with the angles or removing the chest support somehow to where they can get out. So the ease of usability was mainly for the therapists to understand how they felt about the chair. And their results were that for the seat shape, met their requirements. It was adequate for spreading the hips and the posture like they wanted. The braking system itself was easy to engage and disengage. They thought that the angle and height adjustments were very easy to accommodate. And also, one of their modifications that they suggested, this wasn't in the original design, but they noticed while they were testing that one thing that could improve the foot supports was added toe straps that could be attached to the plates themselves to help make sure that the kids kept their feet in the foot supports. And also, after talking to the patients, they agreed that it was comfortable and supportive, and also that they could really feel it working their lower back. Now, all of us take for granted the fact that we can sit in a chair easily without and hold ourselves upright. They, however, cannot. And so the ability of the chair to strengthen those muscles slowly over time is one of the therapeutic reasons why the sponsors wanted the chair in the first place. So, and here's just a picture of one of the patients in the chair. As you can see, the saddle shape is indeed doing its job with the foot supports holding him up fine. And then here's just a side view of the chair with it fully supported, not only the seatbelt but also the chest support. This is a budget of our overall budget throughout the entire project. The left is what we actually spent, and the right was the full cost of everything. Most of what we found, what we had, like structural steel and parts, we purchased ourselves with the help of our sponsors. But some of the things that were done to the chair were donated to us by some of our sponsors. That include half the price of the vinyl covering for the seats, and also the welding and the powder coating were donated to us by ABC Welding. And although we did some of the welds ourselves, ABC Welding did the welds. We needed to make sure that if those parts were designed to where if they were to fail, it would put the patient in jeopardy. We wanted to make sure that those welds were done by licensed professionals, not us. So that's what we had them donate. So that's what they were willing to donate for us. And overall, the chair cost us $1,245. And then just to summarize, the main problem that we had was the fact that most wheelchairs aren't designed for the special type of therapy that they wanted. So our proposed solution was a saddle-shaped seat. I'm sorry, I don't like saying that. We went over the components that it took to make it, as well as the manufacturing that we did, the overall testing that we accomplished, as well as the budget. And the next slide is all of our sponsors that helped make the chair a reality. And I would like to open up the floor for any questions.
Can you operate it for us? Yeah, right there. Run it up and down. Tilt. They want it, once you.
They turn to the
spin around-
side.
50-pound patient there, right?
Yeah, spin around so we can, so we can see this.
Load AJ goes and gets in.
Volunteers, yeah.
Yeah.
And you could, if you hit either tab, it releases both of them. You can push on the side and it still breaks.
Yeah.
So
Simply disengaging one brake, make sure it makes it releases both.
it's not perfect. The height can't, we do have interference, but we expect them to use the height less than the angle adjustments. So we, so, if you could clockwise. And we'll get it dampened and on top.
Overall, it's 38 turns to go from top to bottom. Is that right, Will?
Yeah, I believe so.
38 turns to go fully from all the way to the top, all the way to the bottom.
The angle support is very easy to do. We were testing it, you could just pretty much do it with one finger.
Yeah.
And the foot supports themselves, like the chest support, are designed to lock in place and stay that way. So, as you can see, we added tape measure stickers to it so that anybody that uses the chair, their specific requirements, like what they like, could easily be recorded and remembered so that you could easily put it back in that same spot.
Does the foot go on top of the black plate or in between the
No,
plate and the?
Right on top.
Okay.
The foot support would be right under.
And how do you remove that chest support?
You simply remove this screw and then just take it off.
That's the quick release, or that's, you said you need to be able to get them out of the chair quickly in an emergency.
Right.
You have to remove the screw for that, or?
Take it off, let's see you take it off.
Say something about that.
It's a specialized tool that we use.
The leg supports it the same way.
Yes.
Use that
Yeah,
tool
that's
again.
more sense, that's not good.
That does take a fire.
So yeah, you can take the chest support on there, just a conventional car seatbelt, you just click and it undoes.
Your chest support tube that attaches to the chair sticks up higher than the top of your saddle.
The socket.
You don't think that that's a potential pinch point, hurt point for somebody getting in the chair?
As Richard is thinking, a nut cutter.
That's a two-word.
Yes, sir.
Try to stay away.
Oops.
That's a good point.
Same as you.
Yes, is.
I mean, there's no reason for it to be that high. In your, sketches,
Because that is an elastic seat.
in your sketches, you showed it below the seat. So that's just why that you built it higher.
Because if this was higher, then the higher this is, the shorter this has to be. So if this was really short, this has to be longer. If this is longer, you could hit our retainer because it's sticking out down here.
Put it in the slowest position.
Well,
Man, that's 8 inches.
you still got,
8
Okay,
inches
yeah.
down there. Come on.
and I'm only talking, we're only talking sort of a couple of inches.
That's something that we can easily.
Yeah, it's something. Like I said, the seat is elastic, and so it's don't compress there.
Right.
And so when someone is sitting in there, it even sticks up higher. Yeah, the fact of it is, what you could do, the easiest thing is to move the whole sleeve down.
Move this down.
Yeah, the whole sleeve.
Okay.
You know what I'm saying? I mean, just, and if you have to, then the rod has to be longer to get the maximum height you want. But, and the other thing that I was complaining about is that, I understand why your vertical lift crank is a vertical shaft, but was it necessary for the shaft to be vertical? I know you're doing a chain drive down there, so as a consequence, you got two bearings, and that is the drive shaft, but it seems like maybe you could have angled it a little bit different, got a little bit less interference with the seat. That's all. That's,
Yeah, our initial model, before we lowered the frame,
Yeah.
we had to move that in, and then we just neglected to consider,
to-
you know, our seat actually got wider too when we decided to make it, so both those together made it work.
Okay, so you
We're
so you got a
contemplating-
short handle on that one, and a long handle on the easy one, right?
Yeah, we went to McMain's and we told them we had the option of lowering the hand crank and cutting the shaft to have less interference. And
Yeah.
the other day, they said they would prefer that, so we still have to do that.
Yeah,
So in,
So this is gonna drop down,
yeah, in the business, we call that a bust, where you have the seat and the crank hidden.
right, yeah.
How do you, I see y'all solid, you know, modeled all this in solid modeling, but also see your model doesn't really look like what your chair is in some of those photos. Did you have a solid model of
Well, that was
of
the last
actual?
semester.
The current design?
Yeah.
No, we haven't went back and completely revised our SolidWorks model yet. And for some of the things, like, if it was intended for family use, we would put mechanical stops so that that it could never interfere. But being that, you know, we're gonna show the therapist how to use it, and they want maximum adjustability, that was one of the major things they wanted initially. We allowed interference just because at different heights, that angle can be different before interference occurs. And if we limited it, that angle would be fixed. So it would restrict some motion that they could otherwise use, provided that they, you know, take that into account when they're using it. That was some of our thinking behind it.
Well, one of my points is, I guess, it should hit home with you that the solid model is a design tool, that you can use it to find those things out before you build it. I understand you probably had some developments as you were fabricating. That always happens. Your chair got wider. But, that happens all the time.
Are you meant to remove the tilt angle adjustment handle under normal use, or does it stay in that position all the time?
This,
Yeah,
it's not removed.
okay, because it looks like it could be, well, one of AJ's problems.
You get one for the patient and the therapist.
Well, it looked like in your assembly that y'all welded all of your channel sections together. Why didn't y'all just bend it? Like the seat bracket? It looked like in your picture, you know, you had the flat plate, cut the two ears and welded them on. And just about everywhere you did that, why didn't y'all just bend it? Make fabrication simpler.
Well, with our knowledge in the machine shop, we didn't know that we could bend a quarter inch. I didn't, you know, we just thought it'd be easier to cut it out with the water jet than with welded.
Pretty easy to bend quarter inch plate. Especially even this, you know, even without a press and the sizes you have, you just put it in the vise and heat it up. Then it will hammer.
We also needed it to be straight, some of them needed to be straight on.
They'd be straighter if you bent them than if you welded them. You don't have all the welding distortion when you just bend it.
We just didn't consider bending it.
And like I say, it'd be more for, you know, if you did go to production, you know, mode. 'Cause you can, you know, bend those things real fast and eliminate all the labor to cut, fit, weld, and ensure that they stay straight.
I was pleased to see y'all had some testing in here. It's nice to see some good data that came across. You had torque values. One of my questions, several times you mentioned a torque value on those handles. You mentioned one of your tests required 1.5 meters per second for an impact test. How did y'all measure those two things, the torque and the speed of the chair?
The speed for the impact test was we merely measured out the full distance that he traveled, and then looked at help of a timer and some just basic equations. We were able to tell whether or not he came within that speed. As far as the torque values,
We just had a bar back here with a rope, and we just increased the weight until the hand crank rotated back. You know, we had a bar here, and the rope came over, and then we just had a platform where we increased the weight until this crank rotated.
we made the crank arm and also the force applied at a right angle, so that the second angle we knew that was
So your
kind of-
torque value is too high.
Just about a little bit, yeah.
Yeah, the friction.
Higher than
friction.
conservative.
You got friction.
You don't have the friction of the rope over